Hi, I'm Mrs. Burns and welcome to Lecture 2 for our Chapter 2 unit. Today we will be focusing on rates, but let's recap what we already know. The first thing that we already know is that a ratio is comparing two quantities that have the same units. And today we're going to talk about rates, which a rate compares quantities that have different units. So yesterday we talked about the same units. Today we're talking about different units. So for example, if your car drives 50 kilometers per hour, kilometers and hours are different units. So 50 kilometers an hour would be considered a rate, not a ratio. So let's try a couple examples here. If you take care of your plant and it grows 18 centimeters over 3 months, what's the rate of growth? So we want to know how much is it growing per month. So let's rewrite this as a division statement. 18 centimeters per 3 months. And can we reduce this? Yes, we can. Divide both the numerator and the denominator by 3, and you get 6 over 1. So you don't have to actually write the 1. You can just say 6 centimeters per month. And that's how we would write the rate of growth there, 6 centimeters per month. So when we reduce the rate so that the second term is 1, like we did right there, we would call that a special rate. That's a unit rate. It's per 1 unit. So for example, 18 over 3 centimeters over 3 months. This is a rate. And then the 6 over 1 month is a unit rate. So those are different. When the denominator is a value of 1, we call it a unit rate. So sometimes the fraction is more difficult than just dividing by 3. That's kind of simple reduction. You might need to use a calculator. So let's try, for example, if we were to do that one, we would have done 18 divided by 3 on our calculator, would have given us 6. And so that's how we know that 6 is just a secret fraction and it's really over 1. So let's try one that you would need a calculator for. Cat food costs $9 per 5 cans. What is the unit rate for each can? So we want to know per can, how much are you paying? $9 for 5, how much for 1? Well, we can divide both of these numbers by the denominator, because if we divide by 5, then 5 divided by 5 is 1. Remember that any number over itself is 1. So this is just the same as 5 divided by 5 equals 1. So if we divide the denominator 5 by itself, then that gives us 1 in the denominator. Now 9 divided by 5, that's not very easy. So we can plug that into our calculator and say 9, then push the division sign, divided by 5, equals, and you should get $1.80. So it's $1.80 per can, you can say. There you go. Another example, in this case at Ed's Grocery, one brand of salsa is sold in the following container sizes. You've got a small container, you've got a medium container, and you have a large container. Which one is the best value? So which one, if you're going to eat your salsa anyways, how much should you get? What's the best deal? What's the best buy? So in this case, we can see that the milliliters, how big the can is shown, as well as the price of the can. So let's break it down and do each one separately. Figure out the unit rates. Because right now we have different, sizes, so we can't really compare them. You have to compare per milliliter. So let's change them all to 1 milliliter. So the small, I'm just going to write an S for small. We'll do that one first. That is $3.44 per 425 milliliters. The medium is how much? $6.29 per 642 milliliters. We can see that right on the can here and right underneath it. And then the large, that one costs $15.49, but you get 1.7 liters. Oh, did you just notice that this one, the big one, is in liters? So we're going to need to change that to milliliters. So let's hold on that thought. Hang on a second there. So let's do the small first. If you type into your calculator 3.44 divided by 425, then you will get a value of $0.0081 per milliliter. So that's how much it costs you for each little milliliter that you have in your salsa jar. Let's try this one. 6.29 divided by 642. That will give you a value of $0.0098 per milliliter. So you've already seen here that this small one is cheaper than the medium one. So if you had to just compare those two, then the small one is so far cheapest. It's the best buy. All right, large. We need to change this first of all to be in milliliters because we can't compare liters and milliliters. So this needs to get changed to milliliters. Excuse me. We know that 1 liter has 1,000 milliliters. So we would just times that number by 1,000. So if we want to go 1.7 liters times 1,000 will give us the milliliters, and you get 1,700 milliliters. So you should be practicing those conversions. You get to do that in math and science. So keep practicing, and I will always tell you on any quiz or test what the conversion rates are so you know how to go from one to the other. So $15.49 divided by 1,700 milliliters. 15.49 divided by 1,700 will give you a unit rate of $0.0091 per milliliter. So now we compare the three prices. We have 0.81, 0.98, and 0.91. So the small container is the best buy. So we need to write our answer. The small container is the best buy. That's not always the case. Sometimes it's better to buy the big one, but sometimes it's better to buy the small one. All right, now you know all about rates. Please come to class prepared tomorrow to practice this more, and stay tuned for our next video on proportional reasoning.